Let's take a look at problem 1-2, function machines. So remember, function machines are when we take an input, plug it into an equation, and we get a specific output. So that's what we're dealing with. You're going to have 4 different function machines, and you can see on the screen here that we have 4 functions, and then we have the function machines to kind of show us how this is going to work. The screen here, we have 4 different equations. Each of these will take place inside one of these 4 function machines. We're going to take a specific input, put it all the way through to get another specific output. So as you work, you want to discuss what you know about the kind of output each function produces to help you arrange the machines in the appropriate order. All right, so let's take a look at part A. In what order should you stack the machines so that when 6 is dropped into the first machine, all 4 machines have their effect and the last machine's output is 11? So basically what they're saying is we want to put a 6 in here, and as it works its way through, at the end here, we're getting 11. Something to keep in mind too is we are going to be looking at function notation. Function notation is where we have this f of x, g of x, h of x, k of x. Okay, and this is just the name. So this number, or excuse me, this letter out front is just the name of the function. So we'll be talking about function f, h, g, k. That's a way that we can describe the different functions without having to say the entire equation. And the expression to the right is what this function will equal anytime we put an input in. So don't let the f of x throw you off the h of x, okay? That's just the name of our function, and we're going to be plugging our inputs in for x to see what we get out as our output. All right, so I'm going to give you a couple minutes to try this on your own. So your task is to figure out what order these 4 need to go into our function machines so that when we put a 6 in, we can get an 11 out. All right, pause my video now and try to figure this out in your notebook. Okay, guys, so I put our 4 function machines. I printed them out so that they're actually in the machine now, so we can see where our input and our output are. And the problem told us that we wanted to discuss what kind of output each function produces, so that can help us arrange them here. So we're going to do something called a notice and wonder. So I'm going to start by asking the question, what is something you notice about one of these function machines? So for this first one, I notice that x is being divided by 2. So that makes me think to prevent a decimal, we want this x to be some kind of even number going in. So I notice the dividing by 2. I want an even number. What's something we notice about this equation? I notice the square root. So again, I'm thinking I want a perfect square so that I don't get a decimal out. Something I also notice about this square root is that when we take the square root of a number, it has to be positive. We can't take the square root of a negative number. So I also not only want a perfect square, but I want it to be positive. Okay, so some things that we notice here. This is an exponential, so our x is in our exponent. So I notice that this is an exponential. Does anybody remember what an exponential will do to a number? If it's positive, it's going to make this number bigger. So I feel like this here is going to produce some kind of big number. And lastly, I noticed this negative out front here and a squared. So we know that whatever number we put in here, we'll square it, so it might get bigger, or so it will get bigger, but then we're also going to turn it negative. So I notice that the output here is going to be negative and get bigger because we're squaring it. So it's definitely going to get bigger. Okay, so based on these things we notice, we want to say, okay, what do we wonder? So I wonder which of these function machines should be my starting point based on the information that I'm given. I wonder if I put a 6 in here to start, how big will this number get? Is there anything else that you wonder about our function machines? So I'm going to give you a couple seconds to get these notices written down into your notebook. You can write them by, write out the equation and then write your notices by each of them, because this is going to help us solve our next problem. So I'll give you about 15 seconds to do that. Okay, so I've got our 4 function machines here, and we're going to think about what we noticed as we worked our way through. So we are supposed to put a 6 into our machine and get a 11 out. So if I'm thinking about how these work, I don't think I want to put a 6 in here because we talked about how we want a perfect square. So I'm going to put this one off to the side for now. If we put a 6 in here, okay, let's think about what we're going to get. So we'd have 2 to the 6th power, which is 64, minus 7 would give me 57. Okay, if I think about that, if I get a 57 here, would I want to put a 57 in and divide it by 2? No, because then I would get another decimal. So that doesn't look like that's going to be our best bet. And same over here, if I went from this machine to this machine, I would put 57 in, and I'm going to get a huge number out that's negative. And if we have that big of a negative number, we can't put it into our square root because we can only put positive numbers in there. So we don't want to start with this one. Looking at our next two here, okay, if we put a 6 in here, we would get a negative 4 out. Okay, by putting a negative 4 in here, we're going to get a negative 4 squared, negative 4 minus 2 gives us negative 6 squared, puts me at 36, and it's negative. So I have that perfect square, but it's a negative, so I can't plug it into my square root. So that leaves me with g of x as my starting amount. So let's take g of x and plug our 6 in here. So put a 6 here. So 6 minus 2 is 4. In order of operations, we do exponent next. So I get 4 squared, which is 16. And this gives me a negative 16. All right, so let's put this right here for now. Okay, if I look back at my other function machines, negative 16 would work here because we're dividing by 2. We got that positive number. I can't use negative 16 here because I can't plug a negative into a square root. So I'm going to put that one to the side. And this one here, if I put a negative 16 in here, 2 to the power of negative 16, let's put that in my calculator, 2 to the power of negative 16, I get this number here. And that is definitely not a good number we want to work with. So that tells me we are going to use this function, k of x. So I'm going to plug negative 16 in to k of x. So negative 16 divided by 2 gives me a negative 8. Double negative 8, so negative negative turns this to a positive 8. Minus 1 gives me 7. All right, we're making our way through. Looking at our ones that are left over, I don't want to plug a 7 into the square root because, again, that would give me a decimal. So we'll put that one to the side. And our next that we are going to plug in is a 7 here. So when I have 2 to the power of 7, I get 128 minus 7 gives me 121. Now that seems like a big number, but let me shift my machines over here. But if I take the square root of 121, I get what? 11, yes. So if we look at our function machines here, we plugged a 6 in to start. When we plugged a 6 into g of x, we got negative 16. Then we took negative 16 and plugged that into k of x to give us 7. 7 plugged into h of x gives us 121. And lastly, 121 plugged into f of x gives us 11. So the order of our machines were, we had g of x, then we plugged into k of x, next was h of x, and lastly we had f of x. So using our notice and wonder, we can definitely find a good strategy and an elimination process to solve these. Another method is just a simple guess and check. So by running numbers through these different function machines, you'll start to see what works and what doesn't. So I'm going to leave this up here for a minute so that you can get the order written down in your notebook. Problem 1-2 was a great example of the type of problems you'll see in the CP&M textbook. It was definitely an inquiry-based problem. It took problem-solving skills, critical thinking, and just an investigative approach to figure out the best way to get our input to match the output that we wanted. We will try more problems like this, and you'll get to work with actual teams in the lessons to come. But as we close up this lesson, I want you to scroll down in your book to the section that says Math Notes. So there are a lot of important examples and vocabulary words within this section. If you click on one of the blue words, a definition box pops up for you. And this is going to be important to help you as you study and move forward. I highly suggest at the end of your notes, you write down the math notes in this section. So write down your vocab words. Let me exit out of this. There are some examples drawn for you. You want to know what an independent and dependent variable are, because we're going to be continually building on these ideas and these different skills throughout the next few lessons. We have domain and range, which will be coming up in a few days. So to write down your definition of domain and range would be super helpful. Remember, you don't have to type this out word for word, or write this in your notebook word for word. You can abbreviate it so that it makes sense for you. And that is all of our math notes. Once you have completed your notes from the math notes box, we're going to move on to the review and preview. These are your homework problems. For your homework, you are actually only going to do problems 1-4, 1-5, and 1-9. Put these in your math notebook titled Review and Preview with the problems below. Make sure you show all your work, because when we do come back to school, I will be flipping through your notebooks. I also at times will ask you to screenshot your work and upload it to our Google Forms. So to show all your work from the beginning is going to be your best bet. Have a good night, guys. If you have any questions, please email me.